Today we are starting proofs, which is a really different part of geometry. A proof is essentially a argument. You are starting with some information and you're trying to take it step by step by step. Make a statement, make a statement, make a statement. And every time you make a statement, you have to back it up with a reason, which we call a justification. So you're going to have a 2-column proof. The left side of your proof will be all of your statements. The right side of your proof will be all of your justifications. And so justifications are things like properties, definitions, theorems, postulates, basically all of those math rules that we've been learning, and we're going to keep adding to our list. So at the front of your notebook, we set up a section called proofs, justifications. So in that section of your notebook, you should keep a bank of all the different justifications that we use. So that way, if you get stuck, you can reference that. I also have it on the back whiteboard. So if you want to copy it down off the back whiteboard into your proofs, justifications section, you don't have to define them or anything. Just write the name of them. Okay, so imagine there's a little annoying kid watching you write your proof, and every time you make a statement they say, well, why'd you do that? Well, why are you allowed to do that? Well, why are you allowed to do that? So every time you make a statement, you have to give a reason. So think, why was I allowed to say that? Because of blah blah blah. Why was I allowed to say that next step? Because of the property blah 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 blah. Something like that. So we're going to give you a given. So that's our starting point, and then we're going to tell you what you're trying to prove. So if all else fails, your first step of your proof is just the given statement, and then the last step of your proof is the prove statement. So you should get the first step and the last step correct, no matter what. Okay, here's our first proof. Our given is -5 times x plus 4 plus 10 equals 70, and we are trying to prove that x equals -16. So my very first statement, I'm just going to copy the given down exactly. Don't change a thing, exactly as I see it in the given statement. So -5 times x plus 4 plus 10 equals 70. And my reason for that first statement is, I told you, it's the given. The reason why I'm allowed to say that is because it is the given. So your first statement of your proof is always the given statement, and then the justification is, it's given. Okay, now I want to think to myself, if I'm trying to solve for x, I'm trying to get x all by itself. If this was my equation, what would be the very first thing that I did? So I see this -5 outside the parentheses. So my next statement is I'm going to distribute that -5. So that would give me -5x. -5 times +4 is -20 plus 10 equals 70. And the reason why I was allowed to do that, my justification is that is the distributive property. And you can abbreviate property P-R-O-P period, prop. But you must write the word property. Whether it's all the way spelled out or just prop, you have to put property. You can't just say distributive. Okay, now, third step. If I was going to solve for x, I see I have a -20 and a +10 right here. I would combine like terms. So I'm going to combine like terms. -5x, -20 plus 10 is -10. And whenever we are combining like terms, whenever we're just adding stuff together on one side of the equal sign, that is called simplify. I'm just cleaning stuff up. I'm just simplifying everything. So a common question people ask is, Miss Briscoe, you just added the -20 and the +10. Why is that not the addition property? Well, the addition property is when you add a number to both sides of your equation. And notice, my right side in the second step was 70, And my right side in the third step was also still 70. I didn't add anything to the right side of my equation. And since I'm not adding something to both sides of the equation, it's not the addition property. All I did was combine like terms, which is simplify. But now in the fourth step, I'm trying to get x all by itself. And so this negative 10 has got to go. So if I was trying to get that negative 10 to the other side, I would add 10 to both sides, which would give me negative 5x equals 70 plus 10 is 80. So because I added the 10 to both sides of the equal sign, both sides of the equation, that is the addition property. And then finally, my last step, I want to get x all by itself. This negative 5, this pesky negative 5 is stuck on it. Those two numbers are multiplying. Negative 5 and x are multiplying with each other. The opposite of multiplication is division. So I'm going to divide both sides by negative 5. And 80 divided by negative 5 is negative 16. And that is the division property. Notice my proof statement is the last statement of my proof. They match perfectly. So you aren't done with your proof until the last step, the last statement of the proof is identical to what it's telling you that you're trying to prove. So if they don't match identical, if they're not exactly the same, if they're not identical, you're not done with your proof. You need to add another step to make the very last statement match the proof statement exactly. And hooray, you just wrote your first proof. Big day.